this is David Shreeve, Algebra 2 instructor with Florida Virtual School. We're going to look at a couple systems of nonlinear equations. Even though this top function here is linear, but we're going to look at solving these not graphically, but using substitution or elimination. Now, I would still recommend that after you solve something like this using substitution or elimination that you do put the two functions into GeoGebra and just verify that your solutions are correct. What you could see here, if we think of it graphically, you have a line that crosses somewhere up here at 3 and has a slope of 2, so that line probably looks something like that if I'm just making a quick sketch. And then we have a quadratic, and this has got a negative in front of the x squared, so it's going to be a parabola that's pointing down, probably looks something similar to that. So when we talk about solutions for these, we'll actually end up with two ordered pairs. So they might cross twice. Another scenario, thinking graphically, that we could have a parabola and a straight line and it doesn't touch at all. We could have a parabola here and another parabola there and they don't touch at all. You could have a line just cross and just intersect the parabola at one point. So you could end up with no solutions. You could end up with one solution. There are a few things we could end up with here, but focusing just on this example, if we want to use substitution, this one's already solved out for y here, so you could just plug that linear function in for y in this second function. In this scenario, I would move everything over here to the left. You don't want to, or I don't want to anyway, deal with having a negative coefficient on my x squared term. So I would just add the x squared and subtract the 6 from each side. That would leave us with x squared plus 2x minus 3 equals 0. Once we get it to this point, you can use completing the square quadratic formula. In this case, this one looks like it would be very easy for us to factor. So I would just go ahead and factor this out. This is going to be x plus 3 times x minus 1. So our x values are going to be negative 3 and positive 1, but remember, the solutions are ordered pairs, so I still need to plug these values back in to one of my functions up here to find out what my y value would be corresponding with the x coordinate. So let's plug in that negative 3 first. So I'll just plug it into the first one. It's a little easier. Y equals 2x. Well, I'm using negative 3 for the x value plus 3. So y equals negative 6 plus 3. Y equals negative 3. So when x is negative 3, y is negative 3. So one ordered pair is negative 3 comma negative 3. Okay, and now we have to plug the 1 in as well. So y equals 2 times 1 plus 3, that's y equals 2 plus 3, y equals 5 when x is 1. So my ordered pair here is 1 comma 5. And those would be my two answers. And as I said, you would want to go ahead and graph that. I would just type both functions into GeoGebra. Another thing you'll sometimes see is you might not have these solved out for y, so there are other scenarios you could run into. If that were to occur, obviously just solve it out for y. Alright, hope this helps.